keep showing you how to access the base 12 version of pi using Dozenal geometry, and that it's different from the base 10 version that we're familiar with. So we're creating a geometric pattern on the base 12 Cartesian plane that's going to enable us to divide the circle perfectly into 360 degrees, and that's something that we can't do in base 10. So a Dozenal Cartesian plane is a Cartesian plane where the square 1 by 1 is being divided into twelfths instead of tenths. So Dozenals instead of decimals. Okay, so I've drawn this geometric pattern here. It has the length of 0.5 root 2 across here. So this coordinate is 1 and 0.7. This coordinate here is 0.7 and 1. So what we're doing in this video is connecting this point here to 1 down here where the x equals 1.1, and the same thing up here where the y equals 1.1. So we want to figure out how long is that line. So we've created a long, narrow rectangle here where this length is 0.1 and this length is 0.7. So we're going to go over here and just use the Pythagorean theorem, a squared plus b squared equals c squared. So 0.1 squared, 0.01, 0.7 squared is 0.41 in base 12. 4 12s plus 1. You get c squared is 0.42. So c equals the square root of 0.42. So is that the same as 0.5 root 2, which is that length there? So 0.5 squared is 0.21 in base 12. So square root of that times square root of 2 gives us, yes, square root of 0.42. So we can see that all three of these lengths are the same length. And I've just done one more thing here. I've drawn a 3, 4, 5 triangle where you have the length of 3 root 2 or point root 2, 4 point root 2, and then 5. So 3 root 2, 4 root 2, and 5 root 2 is this triangle. So again, this length is, okay, so we've now created 1/4 of a dodecagon in one quadrant of the Cartesian plane. Of course, we can do that in the other 3 quadrants as well. They're going to link up on these same points. So we've created a 12-sided dodecagon where all the sides are the same length, but these points are not all equidistant from the center. So we have an irregular dodecagon with sides that are all the same length. So the total perimeter of the dodecagon is going to be 0.5 root 2 times a dozen, which looks like that in base 12. So it's going to be 5 root 2, or we could say it the other way, it's going to be the square root of 4 do 2. So that's the perimeter of this dodecagon. So you can look at all this in my book called Understanding Base 12 Math, How to Draw the Perfect Circle Using Dozenal Geometry. We're on page actually 42, and that looks like that.